week we are talking about solving rational equations, and then later we'll get into inequalities as well. So these are equations that involve some kind of rational expression, and we're looking for x values maybe that satisfy the thing. So for example, something like this. This will be the first sort of like fully fledged thing that we'll work through. But again, I've got these several rational expressions in here. And the thing we're looking for is x values that make both sides the same at the same time. So to get into that and to figure out how we're going to handle these, first we need to review some fraction stuff. So we're going to lean pretty heavily on the idea of a least common denominator. So for starters, here are a bunch of fractions. We're adding them together, but start small. Start with something like a half plus a third. How do we find a least common denominator for those two things? Okay, yeah. So find something they both go into. For 2 and 3, the smallest one is 6, right? That's the least common multiple for 2 and 3. The smallest thing they both go into. So that means the least common denominator for these two fractions is 6. 6 is 2 times 3, right? 2 and 3 are both prime, so 2 times 3 is the smallest thing they'll both go into. The least common denominator isn't necessarily, 1 times the other. There might be a smaller thing, but in this case, it's 6. What do we actually do with that? Like, how do we use it? Okay, so we use that to rewrite the fractions, right? If you want to think about this sort of as a picture, maybe. The idea is that we've got 1/2, right? So think about like a pie cut into 2 pieces and you take one of them. That's what the half means. Numerator tells you how many of them, and the denominator tells you like what kind of slice it is, right? A third looks like that. And if we add these together, we need to first put them into common units, right? That's why we get a common denominator. So to get from 2 to 6, what do we need to do? Multiply by 3. So we take the fractions that we have, we multiply by, whatever's sort of missing to take it up to that common denominator. But to avoid changing the value of things, we do it on top and bottom so that this is just a different way of writing 1, right? You're always allowed to multiply by 1. If I multiply by that kind of 1 here, then I can figure out how to write 1/2 as 3/6. Sixths is hard to say. And then 1/3, we need to multiply by 2. So it's 2/6. Still hard to say. Basically, what we've done is make some additional cuts here, right? So that we're talking about the same kind of thing. Now I've got 3 of those, right? 3 slices of, cutting it into 6 pieces, and 2 more. So how do we actually add them? You just add across the, straight across everywhere. Just across the top, yeah. Denominator tells you what kind of thing it is. Once we get them to a common denominator, that's like, so think of it this way. This is apples plus oranges, right? Which I can't really make sense of. When I get them into a common denominator, we've got them into, the same units. So then we just add them together. 3 plus 2 is 5. And what kind of thing is it? Is I cut it into 6 pieces. Everybody okay with that? This is, review from, things you've known forever, but just making sure we're all on the same page. Okay, cool. Well, do the same thing with all the rest of these things then. All right, just a quick check-in, make sure we're on the right track. What's the least common denominator for 2 and 6? 6, yeah. There are lots of common denominators, right? 12 is a common denominator, 18, 24, like they all go into all of those things. The smallest one, though, is 6. We don't have to find the smallest one to do what we're going to do. The only difference would be that if I take one that's not the least common denominator, I might have some reducing to do later, right? Okay, so a half plus a sixth. What do we need to do to, rewrite and stuff? Multiply this by 3 over 3. The other one is already written in terms of something over 6, so we can leave it alone. So 3 over 6 plus 1 over 6 is 4 over 6, which is 2 over 3. Okay. Everybody feel good about that? Yeah? All right. Okay. Well, what if the fractions are 1/2 and 1 over x? What's the smallest thing that both 2 and x go into? 2x. We have no choice but to just multiply them together, right? This is a variable. This can represent a bunch of different things. 2 is just a number. We have no choice then but to multiply them because, again, the tool that we can use to rewrite fractions is multiplying by 1, right? So a half, 1 over x. What do I need to multiply 1/2 by to rewrite it in terms of, x on top and bottom, and 1 over x by 2 over 2. Okay, so that becomes x over 2x plus 2 over 2x. And when we add those together, we get x plus 2 over 2x. We can't reduce anything here because there aren't any common factors, right? That's the only way you can reduce. So, you might see this x over x here and be tempted to, reduce that, or the 2 over 2. We can't because it's not a factor of both pieces, right? The only other thing you could do with this would be to basically reverse engineer what we just did. You could split it apart at the addition in the top and then reduce and work your way back here. But there's nothing else we can do to simplify this. You have to be able to take a thing out as a factor to be able to reduce it. So it's x plus 2 over 2x. So what this gives us now is a way to kind of, in general, right, for just about any fractions we want, take two fractions and combine them into one, and we'll see where this is going in a minute. But everybody good so far? Okay. How about here? Can I multiply this by something to make it look like that? If I multiply by -2, I'd get -2x, right? Not x minus 2. So the way these are, put together is with, subtraction, but, addition rather than multiplication. This is x minus 2. Think of this as one thing and a different thing. What's the least common denominator then if they don't have any common factors? It's just their product, right? Multiply them together. If I treat those as, distinct things, then all I can do for finding a least common denominator is to multiply them together. Which, yes, would be x squared minus 2x, but let's leave it as the factored form for now. Okay. So we've got that to begin with. If I'm going to sort of take these up to the least common denominator, right, multiply in what's missing, what do we need in this first term? X minus 2. So multiply by x minus 2 over x minus 2. And just for emphasis, that's all those parentheses are doing, right? It's emphasizing that we treat that stuff like it's grouped. And the other term, I've already got x minus 2, so we're lacking x. So multiply by x over x. Okay. 1 times x minus 2 over x times x minus 2 plus 1 times x over x times x minus 2. Okay, then how do we actually combine them? They're the same kind of thing now, right? So it's going to be something over that least common denominator. And then we just do whatever operation this indicates across the top. So x minus 2 plus x, which would be add, right? So 2x minus 2. Basically just that, x minus 2 plus x. And then again, 2x minus 2, if you wanted, you could factor 2 out, but that leaves x minus 1, which is different than either of the things in the denominator, so nothing reduces or cancels. So we'll just leave it like that.
Why do we need to
You don't have to. If you want to multiply x squared minus 2x in the bottom, that's fine. Yeah. Think about where we've just come from, though, right? And looking at rational functions and thinking about domain and vertical asymptotes and that kind of stuff. With it factored, I can tell a little more easily that x being 0 or x being 2 would be places where this thing's undefined, right? So that's why I'm tending to leave stuff, written out in the factored form rather than expand. There's nothing wrong with expanding it. You can do that if you want. But the factored version kind of shows me like more information at a glance. Yeah. Okay, good. Anything else so far? Okay. What's the LCD here then? X plus 2 times x plus 7. Basically, all we can do here is if we need to treat these as their, stand-ins for like a variable, all we can do is treat different factors like they're different things. And that means that their least common denominator is just the product of what was already there. X plus 2 and x plus 7, if x is a variable, those don't have any common factor. So I'm stuck with just working with the whole thing. So the first term, 1 over x plus 2, we need to multiply by x plus 7 in the top and bottom. And the second one, we need to multiply by x plus 2. All right, which is going to give me x plus 7 over the product and x plus 2, x plus 2 over the product of both of them. Again, you could expand that if you want. There's not really any reason that you need to. And then combining x plus 2 plus x plus 7 plus x plus 2. So x plus x is 2x, and 7 plus 2 is 9. All right, one more. We've got x plus 2 And then in the other fraction, we've got x plus 2 times x plus 7. So what's the least common denominator then? Yep, x plus 2 times x plus 7. This is basically the same as the one up at the top that was like a half plus a sixth, right? I don't need two factors of x plus 2. So I don't need to like square it. That would be a common denominator. It's just not the smallest one. All I need is to sort of have each like piece that's here included somehow. All right, so x plus 2 times x plus 7. First term, I need to multiply by x plus 7 in top and bottom. The other one I can leave alone, right, because it's already got everything. And so we get x plus 7 plus this thing, which becomes x plus 7 plus 1. So x plus 8. Okay, main thing I want to get a check on right now. Does everyone see where we're finding or how we're finding the least common denominator? Okay. You're okay with it in the like numeric, like
Oh, yeah,
number
yeah, yeah,
denominator
I
case?
just mean,
Okay.
like, I mean, I'm starting to obviously see the pattern, like you're just taking it, but, it just doesn't really make sense.
Okay.
There's the parentheses.
Okay. So let's start with the sort of mixed, like a number and a variable. One of the denominators is 2. The other one is x. If x is a variable and 2 is just a number, then I don't know anything about like the factors of this. I can't put a specific value on it. So if I'm going to get a common denominator, the only choice I have is to multiply those two things together, right? The same thing is true here, even though it looks a little more complicated. X plus 2, just treat that like it's, one thing. X plus 7, treat it like it's a different thing. Okay, so if one denominator is A and the other one's B, and I don't know anything about what A and B like have in common or any like factorization, they're not specific values. The only way I can get a common denominator for them is to just multiply them together. So that's what we do. Okay. So don't get, thrown off by like, the factored terms in parentheses and all that kind of stuff. This is one thing. This is a different thing.
What if, like, for example,
So then we've got sort of 3 different things happening, right? So what would the LCD be then? It'd have to have an x plus 3, and it would have to have an x plus 2, and it would have to have an x plus 7. So basically, like everything that shows up in a denominator somewhere has to be included or like covered in the LCD.
so if it's numbers that don't,
Basically,
pretty
yeah,
much.
yeah. But things don't need to show up more than once. Like there's an x plus 2 and an x plus 2 here, but I don't need to like have x plus 2 squared. I just need to have it included, right? Okay, cool. All right, so before we jump into that example too, I thought of, another thing I wanted to kind of add in here to see why we care and why I'm making such a big deal about this. Let's look at an example, that's kind of a little closer to, stuff that's more familiar maybe. So x over 2 plus 1 over 3 equals 5 over 6. We want to solve that equation. What could you do? Okay, we got to get x by itself. That's what solving means, right? How could you do it? Say it again, subtract 1 over 3, okay. 5/6 minus 1/3. Now to actually clean this up, what do we need to do? Yeah, get a common denominator. So x/2 is 5/6 minus 2/6. So it's 3/6. Maybe I should write that on a separate line. I don't know. Okay, then what? Okay. Times 2, because what happens on the left then? You were dividing by 2. If you multiply by 2, then you end up with just the thing that was in the numerator. So x is 3/6 times 2, which is 6/6, or 1, right? Okay. So in the process of solving and moving things around, we moved this over by subtracting, but then to do that subtraction, we needed to use this common denominator idea, right? And then at some point, we had to deal with the fact that the thing we were solving for was in a fraction. Hey, here's another way that we could approach this that might, save us a little bit of hassle. There's nothing wrong with what we just did. But here's another way we could think about this. Look at the fractions that we started with. What's a common denominator for those? For 2, 3, and 6. 6. 6 goes into all of them, right? Or they all go into 6. Sorry, I said that backwards. 6 is the least common denominator for 2 and 3 and 6. Okay, so I could then do the same kind of stuff that we were just doing. And I could put everything into terms of sixths. And then I could, do all the same stuff that we did here, basically. Just it should feel a little more smooth because like I'm doing all the fraction manipulation stuff at the beginning, right? Like that would work. Check this out though. If I take this thing and multiply the whole thing by 6, what happens? Yeah, like 6/1, multiply the whole thing by 6. You got to distribute on the left-hand side because there's 2 terms there, right? So what's 6 times x/2? Which reduces to 6 divided by 2 is 3. 1/3, so 6/3, but that reduces to 2. And 5/6 times 6 would be 30/6 if we actually did the multiplication. Or if we're, like keeping an eye on what we're doing before we start doing it, something over 6 times 6, those are going to cancel and we get 5, right? So what happened? We identified the common denominator. I multiplied the whole thing through by it, and all the fractions go away, right? Now we're not done. We still have to solve. So I need to subtract 2 and divide by 3. But I take this thing that had a bunch of fractions that, like, it's okay to admit, like, we all get a little uncomfortable when fractions show up. Like, it's fine. But by multiplying by that common denominator, all the fractions, disappear basically. And I end up with something that's a lot more familiar to deal with and to solve. Now, again, we got to the same place. We got to the same answer. So like either way works. There are different variations on both of these things that we could do. Like these are not the only ways you could solve this, but I point this out because where we're going is solving things where variables show up in the denominator, which are going to like just sort of look and feel a little bit worse, right? Think about what we just did here. Did everybody feel pretty good about the first couple? Yeah. And this one too? Probably, And then like around here somewhere started to drift a little bit, maybe, right? Like because the thing looks worse. It's not actually worse. It's not actually any more complicated. It just kind of looks like it is. It's more to write down, right? It feels like there's there's more stuff going on and it's, maybe feels further from things I already know. Well, where we're going is solving things that look like this, right? Things that look kind of like that thing that, maybe a little uncomfortable, where I've got these algebraic expressions involving x in the denominator. So being able to kind of as quickly or directly as possible make all the fraction stuff go away should help us through figuring out, how to solve these things. Okay, so that second example. X over x minus 2 plus 1 over x plus 2 is 8 over x squared minus 4. For starters, take a second to figure out what the least common denominator would be for these three expressions. Okay, so one of them, the denominator is x minus 2. Another one, the denominator is x plus 2. Hey, real quick, just out of curiosity, what's x minus 2 times x plus 2? X squared minus 2x plus 2x minus 4, x squared minus 4. Okay, so this is sort of, a hybrid of both of those things, right? They're both there. If you wanted, you could rewrite it in factored form. This is x plus 2 times x minus 2. What's the least common denominator then? The product, x plus 2 times x minus 2. I wrote minus both times, but now I fix it. By the way, the order doesn't matter, right? Could you use what? Yes, yeah. Or x squared minus 4. Yeah, it's good to be kind of fluid about like having both of those things, sort of in our mind at the same time. Yeah. Okay. Everybody okay with that being the least common denominator? Okay, cool. Now, let's see if we can use what we just talked about to turn this thing that I don't know how to solve yet into something that I do know how to solve. Multiply this by the least common denominator. Add a note or something. Multiply both sides by the L. They make an L. Yeah, LCD. All right, when you do that, what happens on the right-hand side? We've got 8 over x squared minus 4, and we're multiplying by x squared minus 4, right? What happens? They cancel. What are you left with? 8. Whew. That feels easier to deal with than that messy fraction thing I started with, right? That's a good sign. Let's see what happens on the other side. We're multiplying this one thing across two terms. So we have to distribute. Look at them one at a time. X minus 2 times x plus 2 times something over x minus 2. What happens? What cancels? The x minus 2 term cancels, right? It shows up in the top and the bottom when we multiply. We're multiplying by it and dividing by it. So those cancel. What are we left with? X times x plus 2. What about this part of the product? The same thing, only it's the x plus 2 term that cancels. So what are we left with? 1 times x minus 2. All right, so let's recap. We figured out what the LCD was. I've got x minus 2, I've got x plus 2, just on a hunch. I figured out, or I mean, if you know how to factor it, if you're comfortable with factoring, that's fine. Or, you know, multiply those out and see what you get. This happens to be the product of those two things. That means the LCD is just x squared minus 4 or x minus 2 times x plus 2. If I take the whole fraction and multiply through by the least common denominator, by virtue of having found a least common denominator, I've found a thing that has common factors to every denominator in there, right? Like that's what it is. That's in the name, common denominator. So when we do that, we get a bunch of stuff that cancels out. It reduces. Here, x minus 2 cancels. And we're left with this and this. Here, x plus 2 cancels. And we're left with 1, the original numerator, and x minus 2 that, you know, remains. On this side, everything cancels. We just get 8. Well, now what I get to do is say, okay, forget about all that messy stuff I just did. Let's just worry about solving this. And what kind of thing is that? It's quadratic. And that means I get to say the thing again. What do you know about solving quadratics? Right. So do it. Collect like terms first. Quadratic, so we need to get everything moved to one side. 3x's, subtract the 8 over, so minus 10. And what did you get? 2 and negative 5. Okay. Agreed. Quadratic formula, factoring, whatever. Get 2 and negative 5. Okay. So those are solutions. Okay. Can you say that again, but like 100 times louder for the people in the back? We got to check the domain. What do you mean? Okay. This is kind of a just general like way a lot of math stuff goes. We figured out it was a trick the first time. Now it's a technique when we repeat it. We figured out a technique that I could use to take this messy equation that I started with that makes me feel, you know, a little bit uncomfortable maybe, and like I don't feel confident about dealing with. We figured out a way to turn that into this thing that, you know, I'm all over solving quadratics at this point, hopefully. Um, and that's great, right? Yes, this part was a little bit messy. We've got some things to, you know, make sure to spend some time with and get our heads around there. But I got to go from this thing, which I'm, you know, maybe not all that happy about, to this thing, which I should be very excited to see. However, the cost for doing that is that sometimes when you go from one thing to a sort of equivalent thing that's easier to work with, we might lose track of some information, or we might introduce some information that wasn't there to begin with. Go all the way back to the original thing. Look at these rational expressions and think about the domain. What can x not be here? It can't be 2, and it can't be -2, because if x is 2 or x is -2, one or more of these things is going to be undefined, right? For example, if I plug 2 in, I get 2 divided by 0, which is still undefined. So whatever else happens, I can't allow x to be 2 or -2, or I get a thing that doesn't make any sense. Well, what did we get as solutions? I got -5 and 2. But can x be 2? No. You can do that a few different ways. Usually what I do, and you'll see this in, you know, my notes if you look at them, I like to start, like when I find the LCD, make a little note to myself about this and, like, you know, make it flashy, right? Like write it in a bright color or something so that this is on my mind. Because what happens sometimes is that, you know, you do all this stuff and you get so caught up in the like line to line working through it stuff that you get here and you're like, whew, like I'm good to go. I got answers. I'm moving on with my day, right? And you forget that, oh wait, these came from somewhere that I need to, you know, make sure they still make some sense. So x equals -5 is the solution here. 2 does not work because it's not in the domain, because it would make one of the original expressions undefined. Somehow we have to deal with that, whether it's kind of at the front end saying, okay, I got to be on the lookout for 2 or -2. Oh, look, 2 showed up, so throw it away. Or taking these and plugging them back in. Now, when you plug them back in, you don't really need to like work through the whole thing. It's enough to say, hey, what happens when x is 2, and start writing it out and go, oh, 2 divided by 0. No, that doesn't work then, right? Like as soon as you get to a place where you see 0 show up in the denominator, that's enough to know like that can't be a solution. Does that make sense? So I don't have to like work through all the arithmetic stuff. And even if I plug in -5, that's going to be kind of messy here. But as long as none of the denominators are 0, I'm going to trust my work in the middle to say like, okay, it's not an arithmetic thing. It's a, you know, place where it's defined. Okay. Questions about that? Yeah. Okay. Yeah. So you could get, you know, here we got 2, these are like solution candidates, right? And sometimes this is called an extraneous solution, like a thing like this that sort of shows up, like indicates like it works, but doesn't actually, right? You toss that out. I don't know what she's looking at. That's misstuck. Yeah, so you just get rid of that. So these could have no solution. They could have, you know, 2 that look like they work, that, you know, 1 doesn't, or maybe they both work, or there's a bunch of kind of variety in how things can go. Okay. All right, that's it. Have a good day. I'll see you on Thursday.
On the homework yesterday, there was for the graphing, rental functions.
Mhm.
We're gonna have to take a graph